Okay, hello everyone. In this video, I will give you an introduction to Lab 2, RSA Public Key Encryption and the Signature Lab. Alright, so since this lab we focus on RSA, here I give a little bit of RSA background. So RSA was invented in 1978 by these three scientists. And the RSA was taken from the first letter of the last names of these three scientists. So this is the first public key crypto systems, and it is widely used for secure communication. So, and it can be quite easily implemented. The RSA application process usually includes three steps. First, we generate two large random prime numbers, and second, use them to generate public and private key pairs. And last, we use the key pairs to do encryption, decryption, digital signature generation, and digital signature verification. So in this lab, we will start from RSA basic operations such as key generation. Here is the steps of key generation. First, we select two large prime numbers. Usually they are very large, like larger than 512 bits. And second, we compute the n equals p multiplied n, and also compute the phi n, that is q minus 1 multiplied p minus 1. And then we select the e, and we usually select an arbitrary number of e, and finally we compute the d, which d is according to this equation, ed is always equal to 1 module phi n, and then finally we will get the public key en and the private key d. Okay, so as a public key encryption algorithm, the first application for RSA is encryption and decryption. We follow this procedure for encryption. For example, give a message M, we use public key and compute the ciphertext as M to the E mod N. So we get the cipher here. And for decryption, we just use C to the D mod N. So we can prove that this message actually equals N, as we show here. So RSA is very secure according to these properties. For example, if we only know N, it's very difficult to figure out the P and the Q. If we only know public key N and E, we are very difficult to figure out the D, as long as the N is very big, P and the Q is very big. And also, if we know the N and the public key NE and the C, it's difficult to figure out the plaintext M. So the goal of this lab is we want the students to learn hands-on experience on RSA algorithms, including those operations such as encryption, decryption, signature generation, and signature verification. All right. So in order to do this lab, we have to use a library we call the big number library. And this is because the biggest number in C is built-in biggest number in C is unsigned non-null, and the number is just as this big, but the primary number in RSA are much bigger than this number. And big number library also provides big num type, and we can use those APIs and to for a lot of operations such as add, multiply, exponentiation, and the modular operations such as like we used in RSA. So the library manual is shown in this website. You can find almost all the functions and uh, the other useful APIs in this manual page. So we also have a sample code for big number library. Is shown here. For example, how you initialize a big number and how you do the prime generation and how you print the big number out. Okay, so try to run this code. So to run this code, you need to use GCC, the code name, and -L crypto as a label to include the crypto library to compile this file. Okay. So I will introduce tasks 1 to 3 in the next video. Thank you. Bye bye.